All right. So this video is the beginning of a new series. In this series, we will talk about division, okay? And how is division related to polynomials? Well, if you watched previous videos, we have gone through level one, which is graphing factored form. And then we had level two, which is not in factored form, but they are easily factored into factored form so that we can graph. So that's kind of like the end goal, right? And also mentioned about how we love factored form in pre-calculus, right? Also in calculus as well. So yeah, we want to have factored form. But life is not going to be as smooth or as yeah, not as smooth or as easy, okay? As smooth or as easy as it should be. So yeah, so that's how I'm going to start it. So when we talk about long division, okay, or any kind of division here, what we do is to break down the dividend, okay. Well, in this case the dividend is it's a polynomial, so we're trying to break it down to the quotients, or we want to see if something is a factor, okay. And I hope that you still have some of the elementary school knowledge with you, and sometimes, this is called pre-calculus. It sounds very challenging, right? But a lot of times it's just middle school, elementary school stuff being repackaged, okay? That looks a bit more fancy, but it's not really that fancy. For example, like, do you know how to do, let's see, do you know how to do, say 48 divided by 2 with long division? Okay. I would say I dare to say you know how to do it, okay? And you just walk through the thought process quickly, like, oh yeah, I remember that the first thing that I would do is to think of what number to put in here so that well, what number we can multiply to put in here, which is 2 in this case. Then I got a 4. And why do I want a 4? Because I want to cancel it out, right? So I got a 0, you bring down the 8, right? 8, and then you start thinking the same question. You're like, oh, so 2 times what? It's equal to 8. And you say, oh, 2 times 4, it's equal to 8. And they subtract, boom, you got a 0. Okay, right? Right. And also we say, well, there's a zero remainder, which means what? Which means that 48 is divisible by 2, right? Divisible by 2. And what makes the 2 very special? Well, if it's divisible by 2, okay, 48 is divisible by 2. That means, hey, 2 is a factor of 48, right? 2 is a factor of 48. And you know what? Not only you know the 2 is a factor of 48, you also know the 24 is a factor of 48. So this is how you know where the word factor comes in. Okay, it's really, really elementary school stuff, to be honest. Okay, at most middle school. All right. So, but then we're packaging it so that it looks fancier. So same idea. So I'm going to show it to you how it's the same idea. Okay, so do we have a remainder? Is it a remainder? All right, all sorts of things. So right here, now this is like level one of long division. Okay, very simple. Okay, nothing fancy. Okay, no curveball. Okay, simple. So the way I'm going to frame it. Okay, now as I said, in pre-cal we are repackaging stuff so that they look fancy, and I'm gonna unpackage it so that it looks like, the elementary school stuff. So we have 4 terms right here, right? 1, 2, 3, 4. So I want you to conceptually think about this as like little 4-digit number. Okay. It's basically like a 4-digit number. So it's like a 3,857. That kind of thing, all right? That's that idea. It's conceptually, okay? And then divided by what? Divided by a two-digit number known as 12, for example. Okay, 1 and 2, right? 12. So you're basically dealing with a four-digit number divided by a two-digit number, but in a pre-calc way. How about that? Okay. And the way we think about this, it's the same. Our goal, our goal is to create the 3x cube so that we can cancel it out. Okay. Just like how we have the 4 over here, right? 2 times 2 gets you 4. I want to cancel the 4. So, well, how do we get the 3x cube? Well, you focus on this. X times what gives you 3x cube? Okay. X times what gives you 3x cube? That is 3x squared. Now, I put 3x squared right here instead of here for a good reason. Can you guess what the reason is? Okay, I hope you can see something. All right, so the reason is because I want to align, okay, terms with the same power, okay? It's gotta have a very nice habit of showing good notation. Nice organization will be the key right here. So you always want to align them together with the same power, okay, vertically. So x times 3x squared, it's 3x cubed, all right? Now, for most people, they're going to say, oh, yeah, just cancel each other out. Now, of course, they will cancel each other out. But if you're watching this, if you're learning from me, okay, I want you to do one thing. I want you to do one thing for yourself. Now, there's subtraction, right? Now, I'm not only putting a subtraction. I'm going to put a subtraction, and I'm going to use a circle to wrap around it. Okay. I think I hear you asking why. Okay. I'm glad that you asked. Now, why? Okay. Uh, yeah. So why? The reason why is because sometimes you may see negative terms and you don't want to confuse those negative signs with the actual subtraction right here. So by putting a circle around the subtraction, that makes me realize, makes me aware that this is a subtraction action, not like any other negative, not like this negative over here, okay? It's an action that I'm about to do. So you will not get confused with the whole sign thing. As I said, memory, it's really terrible. So you want to use the least amount of memory, okay? And you have a pencil, you have a piece of paper. So hey, let's go ahead and do that, right? Now, because we have two-digit number of two terms times two terms, right? So we're gonna multiply the 2 with the 3x squared as well. So that gives you positive 6x squared. All right. So 3x cubed, gone. All right. These two are gone. So nothing to worry about. So we just have to take care of the 8x squared minus 6x squared, which will be 2x squared. Lovely. And then just like earlier example, we bring down the next term. So we have 2x squared plus 5x. Okay. So we think about x times what? Would give you 2x squared, and that will be a 2x. So x times 2x, 2x squared, and then 2 times 2x, it's a 4x. And just like earlier, I will put a little minus with a circle wrapping around it to make sure that I know that it is a subtraction that I'm about to do. So 2x squared minus 2x squared, gone. And then 5x minus 4x is x. And x minus 7. And, well, I just have to multiply by 1. Okay, x times 1 is x. And then 2 times 1, it's 2. So, all right, so the x would be gone. So now the question is, do you know what the remainder is? Okay, now this is where things could get a little bit tricky. Not the actual remainder process. It's really about the subtraction with a negative number. It's minus 7 minus positive 2, which is negative 9. Okay, so use the long division to divide. We did. So if we want to express our quotient with our remainder, how should we do that? Well, now, so before I show it, okay, I'm going to use a simple middle school example, okay, to see if you can think of how we do things here. Let's just say that I have 17 divided by 3, okay? 17 divided by 3. And you know it's not divisible. That's totally my point. So 8 times 3, no, 5 times 3, it's 15. So you subtract them, you get a remainder of 2. So when we say 17 divided by 3, it's equal to what? Okay. Now, some of you may say, well, it's equal to 5.667. Sure. But it's that's not the exact answer. That's more of a rounded thing because you have to round the last digit. So we're going to use a mixed number, or actually we're going to break down the mixed number. So 5 plus 2/3. Okay. Now, the reason why I'm showing this to you is because I want to show you the placement. This is the remainder, which is the numerator. And what's in the denominator? Well, the denominator, it's our divisor. Okay. So that's how we position our numbers. And then we have what else? This 5, it's our quotient, right? So this is our quotient. So I'm gonna write our quotient first. 3x squared plus 2x plus 1. And then we're gonna write our, well, actually it's gonna be a minus because it's a -9. So -9, which is our remainder, over our divisor, which is x plus 2. And that will be our answer. Okay, that will be our answer. Let me just go ahead and show you the analogy right here. See, that's they are totally analogous, and I'm not lying to you. It's just the same thing, you know, same kind of division that you learned in middle school, elementary school, but it's just a little bit fancier. Of course, I know that's more writing. I know you have all these plus and minus, x cubed, x squared. Yeah, that's why we call it pre-calc, right? It's not, math 1 or 6th grade math. But you can handle this, right? If you see the conceptual, like my goal is this. My goal for this video, it's really about you seeing the parallel, okay? You seeing a strong parallel so that deep in your mind, you're not really struggling in memorizing anything particular. I would say the only thing you have to kind of like memorize is that, hey, be careful with the subtraction. Be very careful with the subtraction, okay? Because people would tend to mess up that part. So if you do that, you're good. Okay, you're good. So practice a few more. And by the way, if I ask you, hey, it's x plus 2. Is x plus 2 a factor of the long polynomial in the numerator, the 3x cubed plus 8x squared plus 5x minus 7? You would say no. And I hope you know why it's no. It's no, it's not a factor. X plus 2 is not a factor because you've got a remainder, it can't be a factor if you have a remainder. It's not divisible. So this is kind of shining the light, okay, or shedding some light down the road, and that is we want to find out some factors. We want to find out a divisor that would produce a 0 remainder, and if that happens, ooh, lovely, mamma mia, it's gonna be so delicious. Okay. So next video, I'll go through more examples of a long division. Oh, there will be some curveball coming to your way. So make sure you don't miss it. Okay.